on section 7.7? They've worn a path diagonally across the campus quad. But the quad is actually a rectangle that Marissa measured to be 70 paces long and 40 paces wide. They've worn this path across. And the students, amazingly enough, go over a straight line. It's crazy. And this is paces of the official unit here, but they ask you how long of a path is that they've worn through, right? How many paces? Actually, they tell you a little more than that. Say, how many paces will Marissa save by going this way instead of this way? So she's got to go from this building to that building. She can go all the way around, or she can go across the beaten path, right? So there's a two-step process to this. I've only graded a few homeworks from this section, but one person did just stop at finding the diagonal. That's not enough. They ask you how much does she save by going that way, right? So we'll say this is her, I just always call this D for the distance there between those two. You can call it whatever, you can call it C like ABC. What would you set up? What formula here? Beautiful. Now, please tell me what is wrong. Can you see what somebody did to get here?
Oh.
What'd they do? What'd they do? Yeah, so they okay, I can take the square root of each piece, and yay, right? But the square root does not play well with plus. If you took the square root of this side, you have to take the square root of that whole side. And it can't distribute across a plus. Cool? We know that's true. I mean, what's a plus b squared? Is that a squared plus b squared? Hell no, right? So what is a square root? It's a 1/2 power. 1/2 powers cannot go across pluses. They don't play well together. All right, so be real careful about making it that easy. You just got to square these bad boys, add them up, and see what the hell happens, right? So you get 4,900 plus 1,600, and that is 6,500 paces, right? And you can actually break this down a little bit. The 100 piece, what's the square root of 100? 10. But to truly answer this question, so if you, one person's kind of stopped here, but they ask how many can she save? Well, if she goes all the way around, how many paces does she do? 110. And to figure out how much she saves by going this way, you can take 110 minus this, yeah. So obviously you should give the answer as a decimal approximation, right? You wouldn't tell somebody, how far is it? Well, you'd save 110 minus 10 root 65. Who the hell are you? Tell me, give me a decimal or something, you know? Okay. So that was the weird part about that. It's a two-step process, right? First you got to figure out how far is this, and then you got to figure out how much does you save by going that way compared to going around. Cool. But these all are almost the same problem. Every one of these problems in here. Yeah?
Can you go over 66 again? I know we kind of touched on it yesterday, but I don't remember.
Oh, yeah. Oh, okay. I'm glad you're asking that, because I think I was looking back at that problem. I had looked at it backwards. I originally had a circle inside. When actually they're asking, and I kind of misread what they're trying to say. What they're trying to say is, what's the largest room where they can reach the corners? That's the piece of that problem that I kind of decided not to read. So if I want to be able to reach the corner, where does my circle actually have to be?
Outside the square.
So this is the radius here. This is going to be the radius. This is going to be how long it can reach. So my circle's actually got to be outside. It's got to be the other way around. The square's got to be inscribed in the circle, not the other way around. So when I first read it, I think I just assumed the kind of problem it was and put the wrong shape inside the other shape. So it still kind of boils down to the same thing. You still want to find that radius. The bad part for you is that radius will now be a part of the diagonal, so there's a little extra work at the end, right? So the first step is the same. In fact, the answer we got last time is the same one for the radius. Because the area of the circle, they tell me, is 3,850. And you remember last time, of course, we know the area of a circle is pi r squared. Right? So then you can solve for pi, you can solve for r. 3850 divided by pi, square root throw that in the calculator, see what you get. Right, I can't remember what you got. I can't remember.
It's around 35.
35.015.
So it's about 35.015. That'll be this radius. So what's the diagonal of this square? Yeah, so the diameter, which is the diagonal, so that works in double shift there, the letter, will be twice. That's the 70.030. What was this, feet? And now you just had to figure out one side of this square. Some of you guys might remember the thing we were talking about yesterday. If I have a square that is 7 by 7, how long is the diagonal? 7 root 2. Remember that shortcut? Maybe. Believe me, that definitely helps out. Are we all good up to this point? I mean, that's basically what we did the other day. I just had the wrong shape inside the other shape, so now you just got to kind of do it backwards. If I have a square whose diagonal is this, and what's this side then? Do I know what this side is? Do you know? No. So I call it x. What's this side then? No. It's a square, so it's got to be x. Right? So if you did set a Pythagorean theorem here, you'd see where that root 2 comes from. What would the Pythagorean theorem say? So you get, look here, you get 2x squared, and then you got to take a square root. See how I'm not even squaring that? Because I know I'm going to take a square root, and that's where the root 2 comes from. That just cancels. And then you just divide by the square root of 2. Alright? Okay. So still a two-step process in that problem. I just had the second step a little goofy because I misread it in the first place. So I'm glad you asked the question, Christopher. Alright, so that was probably the hardest problem in that section. Any other questions from A1 or A2 or yep? Or 7?
9 on 620.
On these problems, just want to know how many real answers are going to be. So, they've got 4x squared. I think that's right. No, 9 and 12. All right, you're out. They got this bad boy, and then what they graph is they graph for some reason. They decided to make this side 0. So they graph this, and they get roughly this, right? So where would the answer be to this? Where's the which is the same as this, right? So the answer to this is the same as the answer to that. They're the same equation. Where would the answer to this be visually? Where's the answer to this here? Shoot. What's it say it wants the parabola to do? It wants the parabola to equal 0. Where's that parabola equal 0? Where's the output 0? Yeah, the x-axis, right? So if I gave you this picture, and here's f of x, and I want to know where's f of x equals 0, how many answers are there? 2, right there, right there. How many answers are there here? 1.
So, I mean, if you look at the picture, it looks like it would be 1.5. But if you look in the back, it would look like 1.
No. The funny thing about that second, you got to be real careful with the directions. How many real answers? That's all they want.
Okay.
Not what is the answer, how many real answers are there, right? So here there's one real answer. And actually this parabola, just to kind of give you an idea, it hasn't moved up or down any. Do you guys see what I mean? Like a regular parabola is this, where it touches. All this is done is kind of like moved over. So this one would look like x minus, let's say 1.5, right now, squared, right? So what would the answer to this be? There'd be one answer. It's repeated. It's twice. 1.5 makes this 0 twice. So that's why there's only one real answer. Whereas the minute I kind of pull it so that it hits it twice, this would look like x minus 4 or x plus 7 or something. So you get those two answers. Do you kind of see what I'm saying there?
So there's still two answers in that one?
There are still officially two answers. They just both happen to be the same. Yeah. In fact, we know there's got to be two answers because second degree.
That's what I asked.
So earlier this class, I had to say there could be at most two answers. But now that we have complex numbers to help us, I can say there are exactly two answers. If it's the highest power 7, there are exactly 7 answers. Some of them might be complex. Some of them might be real, right? But it's really nice to know there will be exactly this many answers to that. It's kind of nice to know that. It's kind of a good thing to know. Okay. So how many answers, real answers, would there be for this? No real answers. There would only be complex answers. That would be a b squared minus 4ac. That piece under the square root, that would be negative. That's why it would come out to be complex. There are no answers when I graph it on a real plane. There are only answers when I graph it on a complex plane. Right? Don't want to freak you guys out. We're not going to graph in the complex plane. But I really want you to see the idea. We only graph real graphs in here. So if there are imaginary answers, we're not going to see them. This is a freaking real graph. Right? I'm not going to see the imaginary answers. I haven't graphed any of that. There's a whole other branch of math where you start graphing the complex answers. Oh shit, that gets freaky. In fact, if you look at my website, and I think I saw the fractal up top. Have you ever looked? Or do you guys know what fractals are? A few of you guys don't. I'm going to get in the computer later. I'm going to have to show you some fractals just to show you. Some fractals are graphs of complex answers to functions. And they get really cool looking. Right? I wouldn't want to do them by hand, but you can get a lot of art out of them, which is kind of nifty. Believe it or not, art comes out of math. All right, so I said way more than I was planning on there, but any other questions to set me off? Yeah?
Number 33 on page 620.
Oh, okay. I love when they have the little aha next to it. And if you're like having trouble, you're like, shut up, book. So they say g of x, and remember I told you, they're not going to let you get away from function notation. Find x, where g of x equals 49, right? Yeah. Now, so what can I put right there? What can I replace g of x with? What is g of x? I want g of x to equal 49, but what is g of x in general? Yeah, good. So x squared plus 14x plus 49, that's g of x. And I want it to equal 49. Now that actually is a really freaking nice question. It's an awesome question. Hopefully you guys agree. I don't want to factor this right now. What do I want to actually do with this? Yeah, subtract 49. It just says solve. It doesn't say solve using this or that or the other thing. Screw that crap. I'm going to do this the quickest way I know. And the 49s go away. I know I want to make this 0. And I have to do that no matter what way I want to do this. Well, unless I want to complete the square root. I got to do that. If I want to use quadratic formula or whatever, I've still got to make it equal to 0. But the great thing is that equals 0. Now what can I do with this?
X.
Take an x out. Don't go like this unless I erase the x. It's still there.
X equals 0.
Always try GCF.
Equal minus.
There you go. Now I get you 2 answers there, right? So when it just says solve or you know, you can attack it whatever way you want to. You don't have to do completing the square or whatever they learn. If they just said solve, do it the best way. And that's the best damn way to do it. Factoring GCF, beautiful. All right, so you get x equals 2. 0, negative 14. Cool. Okay. So the nice thing about that is if you did this visually, here's this parabola. Let's see, that looks to be, yeah. Here's this parabola here. All right, there's g of x. And here's 49. Right? I'll get it wrong. Let's see. Here's 49. So where are the 0 and the negative 14? Wow, shoot. I should actually go with my gut here. Come up here. All right, so here's 49. Because remember, how can you look at this? I want this to hit this. That's the answer, right? Where are these equal to each other? When this intersects this. And they intersected at 0 and negative 14. So if you graphed it, that's what you would see. You have to make your y max bigger, but that's what you'd see. Okay, cool. Maybe, yeah. 583, 32? 42. Ah. Oh, yeah.
Oh, yeah. That would say,
No, I don't think so. That would be mean. If I wrote a math book, I'd have my and then I'd have my oh shit. Oh shit.
And I'd be like, oh crap.
7.6. Yeah, I'm glad you're asking this question. This is a question that should be asked from this section. Most of the people that I'm grading right now are getting the last couple of these wrong because of this. What I see a lot of is people do this. Yay! Yay! Right? Which is really optimistic. And there's nothing wrong with optimism itself. But
It just doesn't work in Math 110.
aw. You could be overly optimistic. Let's say that. You can always have too much of something. Well, actually, that first step is right. It's just that the same old thing about a plus b squared is not a squared plus b squared. If I square both sides, which you must do, and in fact, remember what I said first, get the radical by itself? Well, how many radicals are there? So you can never get the radical by itself because there's two of them. Well, if there's two radicals, how many times do you think I'm going to eventually have to square? Twice. Once to kill one of them, again to kill the leftover, right? So if I square right now, which you must do, I got one radical by itself. That's the best I can do. So I'll do this side. I'm so nice. You did my half of the problem. What do you have to do on this side? Foil. Right? Got to write this bad boy twice. Now, I know that looks tremendously heinous, but if you look at it, F-O-I-L, each one of those is not that bad. Yeah.
When you square the square root, isn't the square root supposed to disappear?
Definitely. So there, it did.
That one.
Am I squaring a square root here? No, I'm not. I'm squaring 3 plus a radical z minus 6. I'm squaring two things, not just one. So over here, that square can attack that square root directly, can't it?
Yes.
Here, that square cannot attack that square root directly. I've got to write it twice. That square does not like plus signs. It can't play well with that because squares are based on multiplication. That sucks. What's something squared? It times itself. Oh shit. So that would be where I put that little symbol, the oh shit symbol. I probably wouldn't sell a lot of my textbooks. And then how do you foil this thing? You foil the same way you do anything. 3 times 3? 9. 3 times this, and 3 times this. So how many of this do I have? 6 of them? See? And then what's square root of something times square root of that thing? That thing. Remember that? Square root of 4.2 times square root of 4.2 is 4.2. Bam. Right? Impress your friends. Equals z plus 9. So that's nowhere near as bad as it looks to foil that out. Nowhere near as bad. What can I do now?
Wait, how'd you get that 6?
Which 6? This one?
Yeah.
Because what's the, so 3 times 3 is 9. And then I get 3 times these,
Okay.
and then 3 times these
Okay.
is 6 times this. Right? There's 6 of them now. 3 of these plus 3 more of those is 6 of those. I'm just combining the middle terms. You don't have to do it all at once if you don't want to. You can show yourself.
Oh.
Do you see it? Because again, I get 9 plus 3 of these
Plus 3 of
plus
those.
3 more of those
Okay, that makes sense.
plus this times this is z minus 6. Cool. So that's where the 6 comes from. I like it. Now what do you do?
Eliminate everything.
Yeah. So one thing I noticed, I always look for this 9s go away. That's nice. Z's go away. What do you want to do with this radical? Get it by itself. I like it. So add the 6 over. And divide by 6 to kill that 6 there. And then square both sides, yeah. If you did leave that 6 there and you squared, it better become a 36 on the next step.
Yeah, I did. Then
I like it.
I got, okay.
It'll still work. You'll just have bigger numbers. They reduce at the end. You'll be fine.
Yeah, still equals 7, so.
So if you square both sides now, that is a z. Z equals 7. Now you better, yes,
Go and give the answer.
you better check this bad boy because you squared the damn thing twice. There's 2 options for it to give you bad answers, so you better check it way the hell up here. So 3 plus 7 minus 6 is 1, square root of 1 is 1. 3 plus 1 is 4. 7 plus 9 is 16, square root of 16 is 4. 4 equals 4, yay. Yep.
Okay, so you've got the 6 square root of z minus 6 equals 6. Where did you get the equals 6 from?
Oh, plus 6, plus 6. Move that out of the way, right?
Okay.
Yeah, get your radical by itself. So whenever there's more than one radical in the equation, you get one of them by itself, kill it. You'll have leftover radicals there, you get them by themselves, you kill them. Kill it. Right. Okay. Yes, sir.
24 on 8.1.
Oh, yeah. So this guy here,
Which page is it?
section 8.1. There, right?
Mm-hmm.
So what's nice about this one? Yeah, it's already kind of collected all the x stuff together, so I just have to, first thing I have to do is take the square root. When I do that, I have to put
Plus or minus.
plus or minus on it. So this side, those cancel. What do you get over there? Plus or minus?
Plus or minus.
7. I. What's up?
That's what the plus or minus. I thought that made it that you don't have to put I.
No. If I have x squared equals 81.
Mm-hmm.
Square root, x equals, I gotta put that plus or minus. Why did I have to put the plus or minus? Exactly why did I have to put the plus or minus? Because I took a square root. Does it matter what the hell's in the square root?
No.
I put that plus or minus without knowing what's there. In fact, how do I do this? X squared equals m squared. How do you solve that?
X equals plus or minus 7.
I think it's square root, I took a square root, oh shit, plus or minus. And then you go, well, how do I do this? Right? That plus or minus is there the minute I take a square root. That next step is just me simplifying the square root that I had to take.
Mm-hmm.
So the plus or minus is not going to go away because, it goes, there's an I there, and then the I is going to go, I don't need to be here. No, it's got to be there. Square root of negative 49 is 7i.
Okay.
Cool.
So
you
that's
do
the
the next
answer?
step down and be x equals plus 8i?
Oh, careful. Next step, I agree with you on one point. You got to get the x by itself.
Yeah.
Are those like terms for one thing?
Oh, okay. That's right.
Got there. See. Let me ask you a real quick question. What is 2 plus or minus 7? 9 and negative 5. Good. So you get 2 separate answers. So even if they were like terms, you should have told me 2 separate answers, right?
Well,
Because I got to
I
the plus and
had
the minus.
2 answers.
Okay.
I had a positive 8 or a negative 6.
Oh, okay. That's a little bit better.
Yeah.
But now you see that they're not like terms, so it can't.
Yeah. Okay.
So A plus BI, the X has to be on the one side by itself, and then
Yeah. The answer for the variable is a complex number.
A plus BI.
A plus BI.
All right.
Okay. So I mean, one thing that comes out of that is, as a teacher, I have to be aware of what I really gotta emphasize. And you notice I do emphasize a lot of things over and over and over until you go, shut up. But that's one of them. It's kind of like, it's real easy to not realize where certain things come from and why they've got to be there. So then when there's other crap going on, you're like, well, why do we need that? But that's there just because I took that square root. The square root wasn't there to begin with. I took it. I better give both roots
Is it because one could be -7 and one could be +7?
Basically, yeah. And the fact that there's an I there is just because it was a -49, not a +49. So the I's got to be there for that. The plus or minus has got to be there because I took a root. Two separate things there, right?
So you don't have to put square root, because I was putting +or-7 and then square root of -1.
You could, but what is the square root of -1? What's the
It's
symbol
I.
we use? I. Cool. Just replace that with I.
Okay.
So remember, like pi is 3.1415, blah, 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 forever. So we said, let's use pi because that looks a lot better than writing an infinite decimal. Yay.
So is that the same as square? So I guess it's not the same as x take away 1 equals square root of 7 times square root of -1. That's not the same?
No, but it would be square root of 49 times square root of -1.
Yeah, that's what.
But the square root of 49 is 7, so the square root symbol goes away.
Okay.
Yeah. Okay.
Still, okay.
All right. Any other questions? Okay, all right. I'm trying to think ahead. I do have to leave a little bit early today. Things are going pretty good with Tasha, so that's good. They don't have to do any exploratory surgery. She just needed some antibiotics. They found some stuff in the gallbladder through the ultrasound, which is actually good news, because then you can just attack that directly instead of not knowing what the hell and have to go in there.
What was her name? Tasha?
Her name's Tasha, yeah. So she should be in there until Thursday and come back out. So I'm a little bit happier, a little bit better. If you were worried. It's good for your math teacher to be happy. Trust me. So we're going to do a couple more sections out of 8. Do a little group work and then do a little preview and then head out probably at 10:30 because I need to pick up my girlfriend and get out to the vet. But anyway, I'm trying to think ahead to what I got to do. Tomorrow the quiz was supposed to be 8-1 through 8-5, so now it's just going to be 8-1 and 8-2 because that's all we did last time.
8.1, 8.2.
Basically, the quiz is almost always covering as much as we did a week, but yeah, 2 classes prior to it. Yeah. So it'll be the first 2 sections out of 8 tomorrow. Yeah. I want to just throw a couple of things at you, see what you kind of think about it. Well, first off, before we jump into 8-5, let me just take one step back. Let's do this, make it 11. Yeah. How do you solve that? Because the first thing you try is what? Factor, especially because there's a 1 out there. If it factors, it should be relatively easy. It don't factor. The only way you make 11 is 11 and 1, and you're never going to make 5 out of that. So what do I use now instead? Beautiful, right? Not completing the square. Quadratic is a shortcut to complete a square, unless I say solve using completed square. And then you go, damn you, Jeff, and then you do it. But since you can use quadratic, what are the 3 things I need to summarize here for myself? What's A?
1.
B?
5.
C? 11. All right, what's the formula I use now?
Negative b plus or minus the square root of c squared minus 4ac over 2a.
I like that. That's all. That sounds like a really weird pledge of allegiance. I negative b to the plus or minus. So now you just plug and chug, right? So negative b, negative 5, give or take. 25 minus 4 times 1 times 11, all over 2 times 1. I mean, it's beautiful, right? I mean, remember the work that went into this formula, though, yesterday? That was ugly as hell. But if I'm going to go through hell like that, using it better be pretty damn nice. And it is. It's just plug and chug, right? So I get negative 5, give or take. 25 minus 44. -19 all over 2. So really the only thing you're going to do is -5 plus or minus, how should I write this? Yeah, you could do this. You got to be careful. Most of us have trouble with where that thing ends. So really put the I out front so you know it's not under the square root. Because the square root of I, think about it. What the hell's that? So let's leave him alone. All right. All over 2. And you can split it up, but it doesn't really matter. How are we doing? Bless you. So that's old news, right? That's what we did last time. We came up with this formula using quadratic, we're using completing the square on ax squared plus bx, oh God. And now that we did all that crap, we can just use it. Just plug it in and go to town. All right, so that's old news. Here's the new news. What if I had,
Fun.
Why do you do this?
just because.
He doesn't hate us, he wants to challenge our minds,
Yes.
give us more data.
Now there are 2 ways to look at this problem. Notice over here, this n and x squared, the answer is going to be x equals something. That has an x to the 4th. The answer should be x squared equals something. But a little bit easier way to look at this is something that we talked a little bit about before. Why do we know this is going to work, by the way? What does this have to look like to either be factorable or for the quadratic to work? What's got to be true about these powers?
The second variable is twice the first.
Yeah, well,
Or
other way around. So the first guy, that power has got to be twice the middle guy. Remember that? Because if it was x10 and I try to factor it be x5, that better be what the freaking middle guy is, or else the whole thing don't work. Right? So here, I know it's what's called quadratic, there you go, in form. That's that's officially what it means to be quadratic in form, is the first power is twice the middle power, right? So the way you do this is, I don't know if you guys remember this, if I let u equal x squared, if I let u equal the thing in the middle, then u squared has got to be the thing in the front. Always, right? If it was x10 and x5, if u was x5, what's u squared? What's x to the 5th squared? X to the 10th. So that's why it's got to be in that form for this to work. How does this form look like now? What's x to the 4th? U squared plus 6u. So now I can use quadratic formula, but it's going to be u equals -b plus or minus blah, blah, blah. Because really, what is this letter here? What's the only important thing about the letter is it's the same as the one I used up here. What's so special about x? Nothing, they just happen to pick it. Like, I like that. We use it in treasure maps. Let's use it on this, right? They could have picked up the letter u. So the formula works. It doesn't care what letter's up there. It's just that's, okay, u equals -b plus or minus blah, blah, blah. So what's b here? 6. So 6 squared minus 4 times a times c is -2. All over 2a, which is 1. Cool? Okay, so u is -6 plus or minus square root 36 plus 8.
44.
44, all right. All over 2. I made this exceptionally ugly, but it's too bad for us.
You can get rid of the bottom.
Eventually, yeah. So you get u equal -6 over 2 plus or minus. What can you do with this radical 44? Good. So you get 2 rad 11. Right. You can break it as 4 times 11, and then square root of 4 is 2. How are we doing?
Is that a B or a 6 on the second part?
That's a 6 now. I was just thinking earlier how much my b looked like a 6.
So that's a B?
That's a b, and that's a 6. So this one equals negative 3 plus or minus square root 11.
What is that U? What is that represent? Sorry.
The form they gave it to me
Right.
looked uglier than it had to, right? As long as the middle guy is half the first guy, right? As long as this squared is this guy. So the U lets me write it, showing me what's important. It says, yeah, the first guy is the square of the middle guy, isn't it?
Okay, I see.
But now it kind of separates the problem out for me. That first problem is find out what U is. Right? And that's just quadratic formula by itself. So I'm not thinking about too many things at once. My second problem is I don't have a U. What was U? X squared. So what equals negative 3 plus or minus root 11? X squared equals negative 3 plus or minus root 11.
So it's kind of used like the I is used in a sense, am I correct? Just kind of reword.
Yeah, actually, pretty much, because I replaces something that kind of is ugly for us to write and easy to make a mistake on. U replaces something that would be easy to make a mistake on or makes it look a little better.
Okay.
I like it. Cool.
Is it always going to equal x squared?
No.
Oh.
If I would have had x10 and x5, it would have equaled x5. Do you see what I'm saying? The only reason it was x squared here is because that's what I wanted to replace. We'll do another one. Don't worry. We'll do an even uglier one. Yeah.
We know that h to the 4 has 4 values. Right? H to the 4 have 4 values.
Exactly.
So now u is have 2 values.
Beautiful. So we know we're not done.
U squared is have 4 values. What are the 4 values?
Oh, we're not there yet, are we? U has only 2 answers. So far we're good. X should have how many answers? I like the way you're looking at it. It should have 4 answers. So that's one reason why I know I'm not done. The most obvious reason I know I'm not done is I haven't solved for X yet. You got U, but who cares? My question is about X. You're like, screw you, man. But what can you do now? If U equals
So
this,
you will repeat the answer 4 times.
no, careful. No. X squared equals this, so what's X equal to? How do you solve for X? Square root. And the minute you put a square root down, you better put plus or minus. So you get plus or minus root, negative 3, plus or minus root 11. Do you care that that's exceptionally ugly? Not really, because you're done. Right? You could get into it and say, what is root 11? I mean, negative 3 minus root 11 is definitely going to be negative. So you're definitely going to have at least one complex number answer, right? In fact, you got to have 2, to tell you honestly. But there will be 2, because root 11 is, let me think. Negative 3 minus root 11, you got plus or minus that. That's cool, right? Negative 3 minus root 11, you get 2 complex answers, plus or minus. Negative 3 plus root 11, you get 2 real answers, plus or minus.
So for the u equals, so like where you said let u equals x squared, so what you did was just plug the L in at the bottom, but change it around. You put x squared equals u, and then you just plugged in u.
Exactly. I replaced the u with what it is, with x squared.
Okay.
So I like to think about the u as the thing that makes it easier to look at, the thing that makes it easier to work with. So let me show you a more direct example.
Plus minus square root. Plus minus.
What about this here? I'm going to take one out of here. Oh, that's right. I want to do that. Let's not use R. Yeah. Cool. All right, guys. So tell me, is this in the right form? How do you know it's in the right form? Exactly. What do you get when you square this? You get that. That's the quick check. What do you get when you square this? You get that. See, that's the quick check. If I square the middle variable, do I get the first variable term? If that's true, you're good to go. So what do I want to let u equal? Square root of what? I wanted to focus on the variable piece, right? So what's u squared? 1. So that's basically what we just said. If I square the middle dude, I better get the first dude. Well, if I can do that, then I can let u equal the middle dude, and the u squared will be the first dude. That's really all that. It's a very direct application of that quick check.
You took the y, the radical from the middle, am I correct?
Exactly.
Why didn't you take the 2, the negative 2?
I actually could have, but that would make it a little worse than it needs to be, because then that would have made u squared equal 4 or something, and then it would have been an uglier thing to factor at the end.
Oh, okay, I see what you're saying.
Because I don't have a 4 there. I have to actually put it in there. It would get gross, trust me.
Gotcha.
If I just focus on this, I can always replace this piece. But if I made, real quick, if I made u equal to 2 root y, u squared would be 4y. Do you have a 4y in there somewhere?
No.
You'd have to multiply by 4 then and do all this weird shit. So that's why I want to focus on just the variable piece, because then I can just work with them directly.
Well, it's kind of like just we focus on the 2, like on the x, we never focus on the 6 in front of it.
Exactly, yeah. So now what's it look like? Y is u squared minus 2 u minus 6 equals 0. We get a little bit hopeful here, but you quickly realize factoring doesn't work, because that would be the first thing I would try, is to try to factor this thing. Do you guys agree with me that this equation looks better than that one? Yeah, right? Now, some of you guys might, I was waiting to see if anybody said this, but couldn't I just add this over, divide by 2, square both sides, right? It's a radical. Couldn't I just
Could, but
do it that way?
that's not the point.
Yeah, that's not the point. I like it. Exactly. So how do I go from here then? What do I do next? I can't factor this thing, so I have to use
Quadratic.
quadratic equations. Cool.
1, -2, -6.
All right, so you guys do that for me. Don't say it out loud when you get it. Try to solve, so it'll be u equals negative b, blah, blah, blah. That's good.